Hey guys, we are back with another tutorial in our vRealize automation tutorial series. And this time we're going to talk about the architecture and components of vRealize automation. First of all, the whole VRA infra can be divided into two parts, which are the vRealize automation appliance components and the infrastructure as a service components. The vRealize automation appliance is a pre-configured Linux virtual appliance. It is delivered in an open virtualization format, or as you can call it, the OVF format, which you deploy on existing virtualized infrastructure, such as vSphere. It hosts the web console, the authentication services, as well as the vRealize orchestrator. The infrastructure as a service component of vRealize automation are installed on Windows machine and are responsible for provisioning of IaaS resources. The installation files for the IaaS components are stored on the virtual appliance. Now that you have a slight understanding or overview of the broad classification in regards to vRealize automation, it's time to discuss these components in detail. So let's get started with the vRealize automation appliance and the components of services that reside inside it. The appliance is made up of 5 components: the vRealize automation portal, the VMware Identity Manager, vRealize orchestrator, vPostgres SQL database, and RabbitMQ message broker. Now, without wasting any more time, let's get to know each and every component of vRealize automation. The first one is the vRealize automation portal. The virtual appliance hosts the VRA portal running on the Apache Tomcat server, which the users log in to access self-service provisioning and management of cloud services. The view of the portal can differ for each user and depends upon the roles and entitlements that the user has been granted. The second vRealize automation component is VIDM, or in its full glory called VMware Identity Manager. It is the component that is responsible to provide authentication in our environment. Previously, in versions before vRealize Automation 7.x, the authentication was handled by the VMware vCenter single sign-on appliance, which was installed on a separate appliance with a database of its own. The newer VIDM offers several features which were not previously present when using the single sign-on appliance, such as its support for multi-tenancy, branding. It also supports multiple new authentication methods and OAuth 2.0 tokens. It syncs and locally stores AD users, which reduces search times and in turn login times. The third virtual appliance component is the vRealize orchestrator. To understand what is the purpose of VRO, we need to keep in mind that VRA is a very capable tool that provides a lot of out-of-the-box capabilities. But it can't achieve everything on its own. If we want to provide custom services or day-to operations to the end user, or achieve integration with third-party tools, and let's say to automate day-to-day manual tasks, we are going to need vRealize orchestrator's extensibility capabilities. The standard master workflow in vRealize automation can be extended to call custom workflows from vRealize orchestrator. You can use default or third-party workflows to modify a machine at any stage of its lifecycle. It allows us to extend the reach of vRealize automation and achieve what is not possible by using VRA alone. Now that you know about VRO, the fourth major virtual appliance component is vPostgres Database. It is a SQL database that holds data for the VRA portal, the vRealize orchestrator, as well as for the identity manager. The fifth component that we promised to discuss was the RabbitMQ message broker. There are multiple vRealize automation services running inside the virtual appliance, like the Horizon Workspace, Xenon service, and let's say HA proxy. Now these services need to communicate with each other. RabbitMQ message broker, as the name suggests, works as a message broker between these services. It acts as a way of communication between these services. It utilizes the advanced message queuing protocol to achieve the same. In AMQP, you have services as both producer and consumer. A consumer service is associated with a message queue where it picks its messages from. The producer, on the other hand, is associated with an exchange which takes the message from the producer and forwards it to the queue of the intended consumer as per the defined rule set. A service can be a consumer for a message and a producer for another. Now that you have a general idea about the components that reside inside the virtual appliance, it's time we move forward to understanding the infrastructure as a service part of this discussion. There are 7 components in the IS part, which are the model manager, the IS web, manager service, DEM orchestrator, DEM worker, agents, and IS database. Let's go over each of them one by one. First up, we have the model manager. Now, business logics, events, and data models are grouped into a model and are managed by the model manager. The model manager holds the core of the business logic for vRealize automation. The business logic contains all the information required for connecting to an external system, such as, let's say, vSphere. This information is used by the DEM worker at the time of provisioning of virtual machines. The model manager provides services and utilities for persisting, versioning, securing, and distributing model elements. The model manager runs on the IS web server. I know that this is going to sound a bit redundant, but the model manager can again actually be divided into 2 parts, which are the model manager data and the model manager web. The model manager data is the one that actually contains all the business logics associated with vRealize automation. You can only install it once. When model manager data is installed, it pushes all its business logics into the IS database. So basically installing it again and again would just be reinserting the same data over and over again. Now, about the model manager web, the machine that hosts the first web component must also host the model manager data component. When you install the model manager web component role, it creates 3 websites on the Internet Information Server, collectively known as the IS websites. The model manager web, unlike its data counterpart, can have multiple instances installed. Second component, as you would have guessed, would be the IS websites. As mentioned earlier, the IS websites are started when the model manager web component is installed. It starts 3 websites, namely WAPI, VCAC, and repository. Now, each of these websites have unique functions. The WAPI acts as the point of contact between the virtual appliance and the IS components. All the communication from virtual appliance to IS components will go through the WAPI website, with some exceptions, of course, which we may talk about in a later tutorial. The VCAC website provides the virtual appliance with the data about the infrastructure. All the data present inside the infrastructure tab of the vRealize automation portal is actually coming from this website. The repository website is the only website that is directly in communication with the IS database. It validates all the requests coming from the virtual appliance. The third IS component is the manager service. It is responsible for the communication between IS components such as DEMS, which you will know about in a while, the SQL Server database, agents, and SMTP. Now, you can run multiple instances of manager service at a time for high availability, but only one will be active at a time. That is, the instances will be in an active standby configuration, which means that while the primary one works, the secondary one only observes the primary manager service in order to take its place in case it stops. During machine provisioning, there exists a master workflow. Whenever a lifecycle change occurs of a virtual machine, this information is sent to the event broker by the manager service, which then passes this information on to the vRealize orchestrator to apply custom workflows during each lifecycle state change. The next IS component is the DEM orchestrator. The DEM stands for Distributed Execution Manager. As the name suggests, it manages the DEM workers. It has three major tasks. It schedules the workflows to be executed by the DEM worker. It pre-processes those workflows. It checks status of all DEM workers just in case any goes down. The DEM orchestrators are deployed in an active-passive configuration. If any of the DEM workers stop, the DEM orchestrator clears all associated workflows instances with that DEM worker so that other DEM workers can pick up the workflows. The next IS component is the DEM worker. It is used to execute workflows or business logics that have been scheduled for their execution by the DEM orchestrator. It is used for execution of workflows on cloud-based endpoints. To be exact, it will be used in case of provisioning in case of cloud-based endpoints and will be used in day 2 operations on cloud as well as hypervisor-based endpoints. In contrast to the DEM orchestrator, there can be multiple instances of DEM worker that can be active at the same time. When a DEM worker is scheduled to execute a workflow, it contacts the model manager to download all the business logics required to execute that workflow. The DEM worker can have a one-to-many mappings with endpoints. The next component in our list is the vRealize automation agents. They're designed to integrate vRealize automation with external systems. Now there are 4 different types of agents. The first one is the virtualization proxy agent. Now they're used to collect data from and provision virtual machines on hypervisor-based endpoints. They're supposed to be installed at the location of the endpoint as they can tolerate high latencies of up to 150 ms round trip time. The second agent is the Virtual Desktop Integration Agent or VDI. They help with registering of virtual machines with external desktop management systems like Citrix Zen Desktop. Third one is the External Provisioning Integration Agent or the EPI agent. PowerShell agents integrate Citrix external machines into the provisioning process. The EPI agent provides on-demand streaming of the Citrix disk image from which machine boots and runs. The EPI agent can also be used to run Visual Basic scripts as an additional step in the provisioning process. The fourth one would be the Windows Management Instrumentation Agent or the WMI agent. This agent allows the collection of information from Windows machines that are being managed by the vRealize automation. The final VRA component is the IAS database. Just like vPostgreSQL holds data for virtual appliance components, the IAS database holds data for the IAS components. It is a Microsoft SQL database. That is all I had to tell you about it. That is all you need to know about it. Okay, that was a long one. I hope we didn't bore you to death with this video. But this topic requires extensive and careful discussion, and that's what we try to do. So guys, see you in the next one. Bye-bye.